Alright YouTube, hello and welcome to video 1 of this tutorial series where we're going to be taking the ESP8266 Wi-Fi module from the current state that it's in here to the point where we're going to be able to upload data to the internet. In this episode what we're going to be doing is communicating with the ESP and sending and receiving information from it. So let's just have a look at what we actually have here. So we have the ESP8266, we have the Uno. This is also applicable for a Mega and a Nano. We have a breadboard, we have 3 resistors, a 1, 2 and 10 kilo ohm resistor. We have 4 male to male jumper cables, and then we have 5 female to male jumper cables. We also have a USB cable for the Uno and an ATX power supply. Now if you don't have your own power supply and you're interested in doing electronics, I would advise trying to make one of your own here. They're almost free to make and there is loads of good tutorials out there. I'll put a link to one of those good tutorials in the description below. Now the reason that we need this power supply is that the ESP runs on 3.3 volts and it uses 3.3 volt logic. The Arduino has a 3.3 pin on it, but that pin can only provide 50 milliamps of current. I've clocked this module at requiring 250 milliamps, so it's not even close to being able to power it adequately. And so alternatively you could use a voltage regulator or just some other 3.3 volt power supply. Right, so let's get started then. So first thing we're going to do is take a male to male jumper and put it from the reset pin to ground. And what that does is that disables the onboard chip on the Uno, so it's not running any programs. All it's doing is communicating with the TX and RX line and the output here. So next what we're going to do is put another male to male from ground to the negative rail on the breadboard. Then we're going to take our TX, which we're going to use as yellow, and put that to the breadboard as well. Then we're going to take blue, put that in our RX, which is pin 0, and put that to the breadboard as well. Alright. Now, essentially what we have here, if you've looked at any other videos, you've seen a lot of people communicating with the ESP via one of these, which is a UART2 serial converter. And this is essentially the very same thing, so there's no real need for one of these, but I got it because I just love buying little things off the internet. Alright, so what we're going to do next is hook the ESP up to the board. Now, if you have one of these, you've probably already noticed that it's not breadboard compatible. It will not go in there. So what you can do is make yourself one of these. Now, what this is just a little piece of PCB board with a few pins and a few headers. So what this does is it spreads out the ESP pins so that they're breadboard compatible. Now, in this video, I'm not going to assume that everybody has those parts, so we're just going to use jumper cables. But that's a very good option. So the first thing that we're going to do is take a red jumper cable and put that to the VCC pin. Then take a blue one and put that to the RX pin. Now I'm going to have a little circuit diagram there as well because it's obviously kind of hard to see. Right, so the next thing that I'm going to do is put an orange cable to the chip enable. Then we're going to take a yellow cable and put this to the TX pin. And then finally we're going to use a green and put that on ground. Right, so let's start hooking this up to the breadboard. I know it's kind of a mess now at the moment with this, but we'll get through it. So, first thing we're going to do is put the ground to the negative rail. We want to keep a common ground between everything. Let's get in focus there. Alright. Then we're going to take the red, which is the VCC, and put that to the positive rail of the breadboard. Then we're going to take the yellow, put that straight to yellow. Then we're going to take the orange and put that there. Now the chip enable requires 3.3 volts to actually enable the chip, but it doesn't require any current, so we're just going to use a pull-up resistor between the VCC line and the orange. Lovely. Now, this is an important bit here. The RX on the ESP, which is the receiving, if you're sending data from the Arduino is using 5 volt logic and the ESP uses 3.3 volt logic. So what we're going to do is step down the voltage from the Arduino by using a voltage divider. So first thing we're going to do is we're going to take our 1 kilo ohm resistor, put that there, and then we're going to take our 2 kilo ohm resistor and then pull that to ground then. Then we're going to take our blue jumper cable and put it in between the 1 and the 2. Now if you don't have 1 and 2 kilo ohm resistors, I'm going to put up an equation there just so you can figure out for yourself how to actually work out a voltage divider. So what's happening here is the Uno is outputting 5 volts and a third of it is being dropped over the first resistor. So what you're left with then is 3.3 volts, which is perfect what we want. And that's actually the setup for the ESP, or the ESP. There's no power here yet, but this is essentially the setup, which it's pretty easy to do. So what we're going to do is then pull our 3.3 volts from the 88 power supply, put that to the positive rail. Then we're going to take our negative and put that to the negative rail. See how everything here has a common ground. Then we're going to take our USB cable and plug in our Uno. Turn on the power supply, and we should now see a red light flash if everything is, yeah, everything looks good there. So a little red LED going on there. Right, so that's the setup. Let's move over to the computer now. Okay, so we click on our Arduino IDE, wait for that to come up. Then we go to Tools, we go to Port, and it's already on COM port 3, which is the port that the Arduino is plugged into. We click on that, go back up to Tools, click on Serial Monitor. This is how we're going to communicate with the ESP. And we're going to, in the command line up top, we're going to put in a command that's known as an AT command. That's how the ESP actually communicates with the computer and with other devices. It uses AT commands, and I'll put a link down below on the bottom. So the most simple AT command is just AT on itself, and that should return OK. So click on that, press enter, and we get OK back. That means that it's communicating correctly with it. Now if you look down in the bottom right hand corner, you'll see the baud rate. Now mine is currently set to a baud rate of 9600, so it's communicating at 9600 bits per second. My one is set to that, but some of them that come out of the box, they're set to 115,200 bits per second. If that is the case, just click on that, press AT, capital AT, and enter, and you should get an OK back. If it doesn't, just scroll down through the other ones, and just try all of them that are in there, and hopefully one of them will come back with an OK. Alright, so that's the end of video 1 of this tutorial series. If you liked it, like it, and and subscribe. And if you have any questions at all, put them down below in the comments, and I'll do my very best to get back to them. Other than that, that's kind of it for this. So, sound.